All right, page two of 4.1 notes. So this is again 4.1, page 2. Okay, so as I mentioned on the first page, it's not always clear which variable is supposed to be your response variable and which one is supposed to be your explanatory variable. For example, right? So you might have some kind of question that's trying to figure out if there's a relationship between GPA and SAT score, right? But then the question is which one of those would be the explanatory and which one would be the response? Well, if the researcher wants to predict SAT scores based on high school GPA, then the GPA would be the explanatory variable and the SAT score would be the response, right? If, on the other hand, the researcher wants to use the SAT score to predict high school GPA, then SAT score would be the explanatory variable and GPA would be the response. And I think that you could argue either way, right? You could say, well, clearly the GPA is affecting SAT score, right? The GPA is what drives SAT score, because if you had a high GPA in high school, then you studied a lot, you learned a lot, and so you probably did well on the SAT. On the other hand, you could argue the other way around. You could say, well, I think it's the SAT score that's driving the GPA, because if you got a high SAT score, then you're smart. And if you're smart, then you got a high GPA. So, which one's a response and which one's explanatory, that it totally just depends on what relationship the researcher is trying to show exists. And it should be pretty clear, if you have questions like this on the homework or whatever, it should be pretty clear which one is which, okay? Anyway, what we want to determine is whether or not there's a linear correlation. And for that, it doesn't really matter which one is explanatory and which one is response. We'll determine if there's a linear correlation between the variables in the same way regardless, right? So we make a scatter plot. Once we've created a scatter plot, we could kind of visually determine if we have a linear correlation, right? So if your dots form more or less a straight line, a positive straight line or a negative straight line, then we would say, yeah, there's a linear correlation. If they don't form a straight line, so if there's kind of this parabola shape or this cubic shape, but it's not a straight line, then we would say probably the variables here are correlated, but there's not a linear correlation, right? So they're correlated, but they're not linearly correlated. And then finally, you could have something like this, where there's not any apparent relationship at all, okay? We're not going to talk about these two things, okay? We're just going to try to see if there's a linear correlation. These things would come up later on in a more advanced stats course, okay? But for us, we're not going to worry about them so much, okay? So a linear correlation is one in which the scatter diagram forms a straight line, more or less. Two linear correlated variables are positively associated if y increases as x increases. Two linearly correlated variables are negatively associated if y decreases as x increases, okay? So now the question, do the variables from example 1 have a linear correlation? And if so, are they positively or negatively associated? Well, here was example 1, right? It was this absences versus grades thing on page 1. And looking at those dots, I mean, granted, there's not a lot of data here, and that's mainly because I just didn't want to give us an example where we had to plot hundreds of points. But looking at these dots, they look to me like they're forming a straight line, more or less, right? It looks like it has that kind of a slope to it, and it looks pretty straight. So I would say yes, there is a linear correlation. And then, are they positively or negatively associated? Well, as x increases, right? So in other words, as you move from these kind of dots from left to right, the dots are falling, right? They're decreasing. So as you read the graph from left to right, you're falling, you're decreasing. That shows a negative association. So there's a negative association between the number of absences that you have, and the final grade you end up with in class, which of course makes sense, right? The more absences you have, the worse your grade's going to get. There's a negative association between those variables. So that's what I would say here. So I would say, do the variables from example 1 have a linear correlation? Yes. The variables are linearly correlated. And then if so, are they positively or negatively associated? They are negatively associated. Okay. I keep wanting to ask you guys if you have questions, but there's nobody in here. I'm the only one in the room. That's going to be, I probably will make that mistake, you know. Anyway, if you do have questions, I mean, post comments in Canvas, you know, and I'll do my best to answer them as soon as I can. Okay. So we can kind of determine visually if something is linearly correlated, but as I said, that's not always good enough. It's not always perfectly clear if there is a linear correlation, and so we want a numerical way to determine once and for all, you know, to be completely sure if there's a linear correlation between variables. And here's the calculation to do that. This is a nasty calculation. I am not going to have us calculate these things by hand. It would just take so long. It would take hours, you know, to compute one of these things. Just to give you some appreciation for it, it's like, so S sub x is the standard deviation of the x variable, S sub y is the standard deviation of the y variable, and those two calculations alone would, you know, take a long time. If you remember doing standard deviations by hand, you know, they take a long time. But then once you have that, it gets even worse, because then you have to compute the z-score for every x observation, the z-score for every y observation, and you have to multiply those together, add them up, and then once you've got that sum, you divide by your sample size minus 1. It just takes a long time, so we're not going to do it, right? We're not going to do it by hand. We'll let StatCrunch do this for us. I don't think I'm going to start a new video here because I haven't been talking that long on page 2. So continuing to talk about this correlation coefficient R, here are some things about it. Here's how we can kind of interpret R, okay? So for one thing, R is always going to be between -1 and +1. If R is close to +1, then there's a strong positive linear relationship between the variables. I didn't give us enough space to fill in these blanks, right? Anyway, there's a strong positive linear relationship between the variables. If R is close to -1, then there's a strong negative linear relationship between the variables. If R is close to 0, then there's not a linear relationship between the variables. That doesn't mean that there's not a relationship between the variables, it just means it's not linear, okay? And here are some different scenarios that you can kind of look at and read through. So here we have a perfect positive linear correlation, a strong positive linear correlation, a moderate one, right? Perfect negative correlation, strong, moderate, no relationship at all. And then here we have something that's not a linear relationship, but there's definitely some kind of correlation here. In both of these cases, R would be close to 0. Okay. In these negative cases, D, E, and F, R would be fairly close to -1, and in these positive cases, A, B, and C, R would be relatively close to 1. Okay. To compute R in StatCrunch, we're going to follow these steps here, right? So if you want to make a scatter plot, you go to Graph and Scatter Plot, right? It's under Graph because it's a graph. So if you want to create a scatter plot, you go to Graph and then Scatter Plot. If you want to compute the correlation coefficient R that we've just been talking about, then you go to Stat, Summary Stats, which again makes sense because this is a statistic that we're computing. Right, it's a numerical summary, so it's a statistic. So you go to Stat, Summary Stats, and then Correlation. Okay, So I'll show you on the next page how we do this. I think I'm gonna start a new video so that I can do the last 2 pages on the same video.